Hi, this is Charlie Calvert, and I want to talk to you just a little bit about Boolean logic, and conditional logic, which are concepts that lie at the heart of computing. As you know, zeros and ones are essential. They're the essential building block of computing. Well, false and true, true and false, are the essential building blocks of logic inside your program. So, how do we capture this kind of logic? Well, the most fundamental way to understand logic in computing is with the if statement. All computer languages have this concept of an if statement, and it is the fundamental building block upon which the logic of programs is written. Grasp this, and you're on your way to understanding the way computers work. The tricky part is understanding how powerful the concept is, but let's not get into that right now. Let's just write number 01 equals 5. Okay? Then let's make a if statement. Let's try to make a judgment about that number. If number 1 is, let's say, larger than or equal to 0, then it's going to be positive. Okay? So we'll say the statement is true. Okay? And then else this statement is false. Okay? So we're saying, is number 1 larger than 0 is what we're testing for. And we get back the statement is true. Okay? Let's set the number equal to 0. And says the statement is true. And then let's say the number is equal to -1. And the statement is false. So we're able to make a very simple decision here. It's called branching. We branch in one of two directions based on a Boolean expression. And here is the Boolean expression that we're doing right now. We're testing is number 1 larger than or equal to 0. And that little expression yields up a result. In this case, it yields up false, 0, or 1, true. It yields up either true or false. Okay? Now, the problem with this kind of statement is that you can only go so far by having a simple if statement. And you've seen that you can write a series of if statements so that, for instance, if we had another number in here, number 02 equals 5, for instance, we could write one if statement followed by another if statement followed by another if statement to compare them all. Well, that gets painful after a while. So there's a thing called, rather than writing a series of if and else statements, which is useful sometimes and is often the only way to proceed, but sometimes in cases like this, we can write what are called conditional statements. And let's go ahead and do that right now. And let's say we're going to try to find out if both numbers are positive. So we're going to use an and here and say number 02 larger than or equal to 0. Okay, so we're asking, are number 1 and number 2 larger than 0? Okay, and we run that, and as you can see, the answer that we get back is the statement is false, right? Okay, so it's not true. Let's make it true for a second. We'll put them both in here, and now you can see the statement is true as the result of where we run it when we press Control F5. Now, let's make it false again. Okay? So it says the statement is false. It's not true that number 1 and right? And number 2, that statement that expression 1 and expression true are yielding true. Instead, let's ask another question. Is one of them true? Is number 1, is expression 1 true? Or is expression 2 true? Okay? So let's ask that question, and as you can see, the statement is true, right? Because it turns out that one of them is true. So let's put them both equal, okay? And now the result comes back, the statement is false, right? Neither of them are equal to it, so it doesn't satisfy our goal. If we made them both positive, the statement is true, right? So what was the difference there? When we had and, they needed to both be true for it to work. When we had or, one of them had to be true. So what happens in this world is that you can come up with increasingly complex statements, okay? So that we could have, for instance, let's just add in one more. Number 03 equals, say, we'll call it 7. And then we'll say, or number 03 larger than or equal to 0. Okay? So now we're asking 3 questions. We're saying, are one of those 3 numbers larger than 0? And as you can see, that statement is true. Now let's set one of them to not true, but the statement's still true because we're asking, is expression 1 true, or is expression 2 true, or is expression 3 true? All we're asking is that one of them be true. Now let's make a little substitution here, and let's substitute for or the, oops, we didn't get it, did we? The and. Okay? And we replace all, and you can see now that we've done that. And we run that, and you can see now the result is false, right? Okay? Here's another way to look at that if this is confusing to you. Let's take the 2 statements, and let's put them both on the screen at the same time. But let's down here do an or, and up above let's do an and. Okay? So we run them, and you can see what we got. The first one is false. They're not all true. The second one is true because one of them is true, right? See how that works? So let's make them all true again for a second. And now both statements are true. And then down here, let's make 2 of them be negative, and we run it, and you can see that the and doesn't work, but true still works because at least one of them is working. Now let's set them all equal to false. We run it, and as you can see, everybody's returning false. They're just not happy with that solution. So the bar, one way to think of it, the bar is set high when you use and. Everything's got to be true. And the bar is set low when you're doing or. Only one of the things has to be true. Okay? So I think good next steps now would be to create your own version of this program, or see if I've placed one online for you to play with, and try changing some of these numbers. Maybe make some of them negative, some of them positive, change the numbers altogether to some other values besides 1, 5, and 7. Maybe change the int to a car, in which case you'd have to make some changes down here. You might also consider reformatting some of these lines, see if they're easier to read in this way, or is it easier for you to read them this way, or does it depend a little on the case? Both ways are perfectly legal as a way to format them. Choose the one you like the best. And sometimes you will mix them up. You can have one way and one the other way, depending on what's easiest for you to read. You might want to just change them back and forth as you're playing with them. Get up online, ask questions, do your best to understand Boolean logic and conditional logic. It's very good stuff. All right, thank you.